This is from the 2022 Examcraft mock, option B. It says part of the graph of the curve y equals e to the power of x for x greater or equal to minus 4 is shown below. So that's this function here, y equals e to the power of x. And it says complete the table below by calculating each value correct to 2 decimal places. Okay, so again, the function is y equals e to the power of x. So we know when x is 0, we'll have y equals e to the power of 0. Anything to the power of 0 is equal to 1, so we get the point 0, 1. When y is equal to 0.5, it turns out that, or when x is 0.5, y will be 1.65. When x is equal to 1, y will be 2.72. When x is equal to 1.5, y will be equal to 4.48. And when y is equal, or when x is equal to 2, y would be equal to 7.39. So we can't quite see that on the graph. It doesn't go quite that far. But if we extended it out to there, that would be the point 27.39. Okay, so what the trapezoidal rule does by creating a number of trapezoids is it allows you to get an estimate of the area in this region here. So an estimate of that region. Now, in our case, what it would be doing is you would be creating a number of trapezoids, each of a width of 0.5. Okay, let me zoom in a bit. Each of a width of 0.5. Let me just try that one more time to make that look a bit better. Doesn't want to play ball. For some reason doesn't want to draw that in. Not responding now. But anyway, let me talk while we're waiting for it to come back. So we make these trapezoids each of a width of 0.5. And what we do is once we get the area of all of these trapezoids added together, that allows us to get an approximation for the area overall. So this would be 0.5 comma 1.65, and I could use a formula to calculate the area of that trapezoid. But of course what I want is the area overall, so I would have to add them together. But there's a thing called the trapezoidal rule, and what it does, it allows us to calculate this estimation by saying the area is equal to h over 2, where h is actually the width. Okay, h is equal to 0.5 in this case. So h is the width, and then it's the first height plus the last height plus 2 times the sum of the remaining heights, yn minus 1. And I'll just go through what all that is. So in this case, right, again, if you could use your Casio calculator, you could say mode 3 on your Casio, or menu 3 on the new Casio, mode 2 on the new Sharp, and you'd say f of x is equal to e to the power of x. You'd say start, where do you start, equals 0, where do you end, equals 2, and your steps would be 0.5. And your steps are the same thing as h, it's the width. Okay, it's the width. So in our case here, h is equal to 0.5. Now this is y1, your first height, and this is yn, your last height. Okay, y2 would be the 1.65. So y1, y2, y3, y4, y5. But y5, of course, is going to be yn, my last one. So y4 will be yn minus 1, second last one. So basically, we fill all those in, and we're going to get an estimate for the area. So 0.5 is the h, the width, again, the gap between 0 and 0.5, or between 0.5 and 1. Y1 is 1, yn is 7.9, and is plus 2 times the sum of these guys. You get 6.52. And it's unit squared, obviously, because it's area. You then use integration to get the exact area. So I'm going to integrate e to the power of x with respect to x from 2 to 0. The thing about e to the power of x, when you integrate, it has a unique feature that it doesn't actually change. So e to the power of x integrates to be e to the power of x. So you get e to the power of 2 minus e to the power of 0. And that turns out to be 6.39 units squared. So obviously it's a little bit different. This is the exact, or the actual. You're then asked to calculate the percentage error, and I'll just show you how you do it. Percentage error is error over actual multiplied by 100 over 1, and the error is the modulus of the actual minus the estimate. And so in our case, it'd be 6.39 minus 6.52. So it'd be the modulus of minus 0.13, which is 0.13. Okay, so that's my answer for the error. And it didn't matter if you had it, if you put these two guys the other way around, you know. Your error is going to be kind of classified as a positive number, okay, because it's the size of the error we're looking for. So it's error over actual multiplied by 100 over 1. So it ends up being 2%. The final part of this question was to draw the inverse function. So this guy here was y equals e to the power of x. This would, let me just have a quick look at the question, make sure we're doing the right thing. So it's the inverse function. So it's going to be the inverse function of e to the power of x. And the inverse of e to the power of x would be the log x to the base e. That would be the inverse function. So in this case, there's two different ways to do it. This would be the line y equals x, which would contain the points, say 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, etc. So one way to do it is you can just pick any point you want, go to the line at 90 degrees, pretend this is at 90 degrees, and out the far side the same distance, and you will land on the image. Okay, so you could do that, or as we've seen before, you could take a few points. For example, this is the point 0, 1, and if you switch the x and the y coordinate around, you're going to have the point 1, 0, and that would be on the inverse function. If we pick another point, well, we know the point 1, 2.72 is on the original, so then the point 2.721, so 2.72 comma 1 will be on the image. So you just switch the x and the y coordinates around. Okay, that was the answer for that question. I hope it all makes sense now.